Okay, today I'll be showing you about naval gunnery. Um, Except in this one, we'll be dealing with targets which are much further than what I was showing you in the first example. So, in this example, your ship is right here. Your vessel is going about 30 knots, and the target vessel you want to hit is going 36 knots. So it's going 6 knots faster, so you'd have to lead 6 knots. So in 1 knot is equal to 1.1 miles, and in 1 mile there's 5,280 feet, so that's 5280. Let me do that again. 6 times 1.1 times 5280, and there's 3.3 feet in a meter, so that's 10,560 meters per hour. That's how fast this thing is moving ahead. So that would be about 10.56 kilometers. So right now I have 10,560 meters per hour. So in 1 hour there's 60 minutes. So that's 176 meters per minute. And there's 60 seconds in a minute, so divided by 60. So that's 2.93 meters per second. That's how I derived that number. So in 1 second, this ship will be 2.93 meters ahead. However, there's a problem. The gun's velocity is only 850 meters per second. So we have to find out how long it is going to take your round to get here, to traverse 7,000 meters. So we have to get 7,000 meters divided by 850 meters, and we get 8.223 seconds. That's how long it would take for your round to get to 7,000 meters. And 8.23 seconds, in 8.23 seconds, this target will be 24.11 meters away. So instead of having this little triangle, we'd have to have a big, longer triangle. So this triangle would be, the base of the triangle would be more. So this is a new triangle that we have. So we know what x is. Now the new x is 24.11 meters, and y we know is 7,000 meters. So what we have to do to find r, which is this thing, we use a Pythagorean theorem, which is x squared plus y squared equals r squared. So since we're trying to look for r, it's r equals the square root of x squared plus y squared. So that's what we use. So square root of 24.11 squared plus 7,000 squared. So let's see what that is. Plus 7,000 squared plus square root. So we get about 7,000.04 meters in terms of r, this distance right here. So what is this angle right here? What is this angle going to be? This theta right here. So the way we find it is we have to use arctangent. We could use arctangent. We could use arc cosine or arc sine. Either one of them should work, and they should all give us the same answer, which is 89.8 degrees for all of them. So let me demonstrate. So we know y is 7,000 and x is 24.11. So the answer is 290.34. There's no units, so that's just a number. So we need the inverse tangent of that. So that comes out to 89.80 degrees. So this degree right here. So since it's 89.8 degrees, we know that's 90 degrees. And there's 180 degrees in a triangle. So that degree is only like 0.02 degrees. Okay. So the next thing we do is, let's see for our cosine. So cosine is x over r. And we know what x is. It's 24.11 meters. We know what r is, which is 7,000.04 meters. So it's 24.11 divided by 7,000.04, and we find our cosine of that, which is 89.8 degrees also. Let's try sine. So we know what y is, 7,000. R is 7,000.04, so that's 0.999 or just 1. So we'll find the inverse sine of that, which is also 89.8 degrees. So it's all the same. The answer should be the same. It should be consistent. So let's say this target was going 55 knots. Then the angle would be less than 89.8 degrees. It'd probably be like 80 degrees. I mean, the faster the target is moving, the more you have to lead, so the angle is going to be less because you have to aim further. So that's all it is. You do have to use a little bit of trigonometry when you calculate this stuff. Okay, thanks for watching.